Hello, everyone. So sorry for the delay. I was having some computer troubles, but we got everything worked out and we are here now. And welcome to uh, this week's live Planetarium show. I'm Jessica. I am the Planetarium director. We've got two of our students here with us tonight, and I will let them both say hi. We'll start with Allie.
Hi everyone, my name is Allie and I am a chemistry and biochemistry student here at UMD.
I'm Luis. I'm a chemical engineering student at UMD.
Awesome. So tonight's show is our monthly installment of Ask an Astronomer. So we are here to answer your questions. Go ahead and leave those in the comments if you have any. I'm still trying to get my head back in the stream and not in tech problem solving mode. But while we wait for questions to come in, I know we had some cool things to share with you, and Allie, I'm going to let you start since I am not ready.
So something I'm super excited to talk about tonight and bring to the table is an article. Jessica might want to link that in the Facebook chat from astronomy.com. So some recent news. Actually, I think that it was like publicly released yesterday or within the past couple of days. But there is an asteroid named Rygu. And samples from the asteroid that were collected by a team of American and Japanese researchers were found to contain uracil. And uracil is a very important organic molecule that is in molecules of RNA, which are like single-stranded copies from DNA that are really biologically important because they are like codes for proteins and amino acids that basically make up your whole body and govern the function of your whole body. And this is really important, and this discovery is super, super important for astrobiology and prebiotic chemistry because knowing this now that an asteroid from space, the sample was taken from the asteroid in space, not on Earth, brought back here and analyzed, contained uracil. So even though it has gone through a long journey, exposed to a lot of radiation and the harsh conditions of space, this biological molecule was still found and intact. So that was a super important discovery, and now this opens up to another door for talking about, is there alien life? Where can we hunt for alien life? So yeah, just something really exciting. If you are interested in reading more about uracil and the asteroid Rygu, I believe the link to the article will be posted in the Facebook chat for you to take a
Yeah,
look at
can
that.
you send that to me again since I had to restart Zoom? I don't have it anymore.
Okay, it should be in the chat.
Cool, cool, thank you. And I will go post that right now. There we go. No, this is really exciting because, I mean, one of the talks always about, life forming here on Earth has been where did the building blocks come from? That life built from. And we're finding them on asteroids and comets. So it's possible that some of these building blocks were actually brought here through all of these impacts that happened in the not early solar system, not early universe.
It's also really cool too because this is the first time where we are confident that it's not a like contamination from us. Like I know they've like looked at other asteroid samples that
Mhm.
have ended up on Earth and have found like similar organic compounds, but now we know like for sure that this did not come from Earth and it was a sample that was like isolated and brought to here like from space.
Yeah.
So I just think that is so cool and it's really exciting, and I feel like it just opens up more like questions for us to answer. So really
Yeah.
exciting.
And it also shows that these building blocks seem to be pretty common. And like if conditions are right, they form. Which, as Ali was saying, does lead to the potential for life maybe easily developing somewhere else as well. I mean, if they have the building blocks, um, It's part of, part of this question, we don't quite know how they went from building blocks to the first actual life. So there's, a lot of question in how easy is that step to make. But by searching for life, and of course continuing to study the various different forms of life here on Earth, we will hopefully be able to narrow that down, or at least find out if it is an easy, I hate using the word easy, but an easy process. Because if we do find life is common, then that step from organic non-life material to life must be an easy one to make if you have the right conditions. So no, it's exciting, and part of why we do, still send missions to asteroids and comets, and why we do still want to study these, because they are the original building blocks of our solar system. And so those tell us what those conditions were like, what conditions then led to the Earth forming and developing and life forming here. And so that's why, we're still doing it. And yeah, I know, we always get the question, why are we still sending spacecraft? Why are we spending the money to do this? That's why. Also, just knowledge, right?
Yeah,
Knowledge is always
it's
good.
interesting. It's interesting you bring that up because for a class right now, I'm writing a research paper and going back into primary articles related to like life in the solar system, life in the universe, a lot of like astrobiology, prebiotic chemistry stuff. And one of the biggest questions like is still on Earth, like how did life start on Earth? So also like sending these missions to asteroids and collecting information about organic molecules there also helps us answer like questions about biology on Earth. Like it's not even just about going elsewhere to find life. It's there's so much we don't know about life on Earth and so many like missing steps that we just don't know in evolution. So it's super important just for our biology too to understand like how life started on Earth.
Yeah, because again, those were the building blocks that formed Earth, right? If we want to know more about us, we got to study those too. Which, speaking of, is another. Sorry, Louise, did you have something?
No, I just said yeah.
So to make sure I didn't cut you off.
No, you're totally good.
But I know it also comes up when we talk about places like Venus. We know Venus, hottest planet in the solar system, not something that we ever expect life to thrive on or exist at all, at least not anymore. And so I know there's sometimes questions of, well, why are we continuing to send missions there? Or because we do have a couple new missions going out there. It's been a little while. I think Magellan was the last mission spacecraft to orbit Venus. That was in the late 1990s. But part of it is kind of to answer these same questions as well. Right? Venus actually started out very much like Earth, but we know it's completely different today, and understanding that process can help us in making sure we don't end up like Venus, because it started out Earth-like and now is very much not. Which I totally just did this as a segue to talk about the new evidence of volcanoes on Venus, which came out.
Yes, yeah.
Yeah, I am so excited about that.
Wild.
So, a little bit of context. Venus does have volcanoes, just like we have here on Earth, but up until recently, it has been highly debated and very unclear whether those volcanoes were still active. Now, we think they should be because Venus is about the same size as Earth, right? It's just a little bit smaller. But because it's the same size, it should have the same amount of heat to drive things like volcanic activity and what we call internal heat. Because how much internal heat you have is largely determined by how big of an object it is. Smaller things cool off faster, which you know that from life experience. So small things like Mercury and the moon cool off really fast, which is why they're not active now. Bigger things like Earth and Venus cool off much slower, so they still have a lot of heat inside, and that drives things like volcanoes. So we expect Venus to be just about as geologically active as Earth is, but we have never seen direct evidence of volcanic eruptions on Venus. So we didn't know if it was or not. It should be, but if it wasn't, then why is it not? We've had some indirect evidence looking at things like the amount of sulfur in the atmosphere can indicate if there's been a recent eruption. But just last week, a paper came out that showed the first actual like physical evidence of a recent volcanic eruption. Looking at a couple of volcanic vents on the surface of Venus, you can actually see how they have changed shape over a short time period. And the only model that creates that much change in that amount of time is a volcanic eruption. And there's also evidence of new lava flows nearby as you see changes to the surface. So it's really exciting that we actually have our first real concrete proof that Venus is still volcanically active. And this, yeah, again, why we're sending more spacecraft there, because we can learn more about it. I apologize. I'm going to try to remember to mute before I cough. I'm dealing with a little bit of a cold. So yes, apologies for the sickness going on right now. Let's see. We got a couple of questions. Have you touched on chirality of organic molecules? No. I'm going to be honest, I know very vaguely what it is, but I don't know enough to even talk or teach on it right now. That is
Louise
something.
and I both have taken organic chemistry.
Go
so
for
I know
it.
for sure.
Go
So this
for
is
it.
a really hard topic to like teach students, especially because you have to like almost visualize it. But basically, chirality is a term that's used in chemistry and organic chemistry to describe the orientation of a molecule. And I think the best way how I was taught to think about it and how I think is helpful is if you have both your hands, they're both your hands, but they're not the same, because if I were to flip this hand over and stack it on top of the other one, like my thumbs are on opposite sides, so they're not the same. So kind of like how you look at your mirror image, we see that a lot in organic molecules too, and that's really important for their functions. Like some molecules might be like right-handed and have a completely different function than molecules that are left-handed. This is also an example that some of you may know is in, I think it was like the mid to late 1900s, there was a really big problem with a certain drug that pregnant women were given, and the right-handed version of that drug cured nausea, and the left-handed version caused birth defects. So really, really important that you get that right for which molecules are like right-handed and left-handed. And in the case of like amino acids, I believe that this article touched on it too, but the left-handed amino acids are more biologically used by life on Earth than the right-handed ones were. And on the asteroid, both versions were found. So we're good there. But yeah, chirality, it's kind of hard to think about. Big takeaway, think about mirror image. Sometimes orientation is different. Stack your hands on top of each other. They're not the same, but they are both your hands, and they both have 5 fingers. If that is a good, somewhat explanation of it.
I think that makes a lot of sense.
It's better than I would have done.
I am in organic chemistry right now, so we talk about this stuff all the time.
Yeah, I took organic back in undergrad, and I'm not even about to just make myself sad by thinking about how many years ago that was. It was yesterday. That's how I feel anyway. I did not like organic chemistry.
It's not for everyone. It gets a bad rep. I think it's okay. There's certain things are better
It's
than
just
others,
a
I think.
lot more memorization heavy than I like. I also have really
Yeah.
bad times with um, visualizing kind of in 3D. So like trying to visualize the molecules and like it was just really tough for me.
I have with me right here my organic models. You can get these. If you want to learn more about organic chemistry, you can buy these cute little models and then you can make your own little molecules. So whether you're a student or not, they're really fun. My dad right now is taking chemistry. He's not even in organic chemistry, but he has one of these kits and it's really helpful. So
That's cool.
if you want to practice your chirality, get a model kit.
That is very cool. All right. So let's see. There's some discussion going on about chirality. Oh, hi, Mom. My mom has a question. I saw a Facebook picture of the surface of Pluto. I haven't had a chance to read the article, but I had no idea. You had no idea there was a mission? I mean, I'm not going to completely shame you, but you're my mom. You should know this. Yes. So the New Horizons spacecraft is what they're talking about, which flew by Pluto in July of 2015. So it has been a while. But there was a lot of data sent back, so much that we're still going through it. So I don't know exactly which article you're talking about. I do know recently more results have come out from the data from New Horizons. So that's probably what you saw. But yeah, no, there's still a lot of work being done from that mission, just from the sheer amount of data that was sent back from that flyby, and it was just a flyby. But I think the thing that like really shocked us the most was Pluto looked nothing like we expected it to. Right? Pluto is smaller than our moon. I think it's like 2/3 the size of our moon. Um, It's a big ball of ice, mostly ice. So we expected to see a geologically dead, because it's small, it cooled off very quickly, ball of ice covered in craters. So think, the moon, but made of ice and smaller, but covered in craters. And that's not what we found. We actually found surfaces on Pluto that have no craters, which tells us that Pluto has been active, geologically active in the past couple 100 million years, which we never expected to find. Small icy bodies like that can be active, but that's usually because they are moons of a planet. And as they orbit the planet helps to heat them up and keep them hot inside and drive that activity. But Pluto's by itself. I mean, it has 5 of its own small moons, but nothing that can create that amount of heat to drive activity like we were seeing. Um, so there is a lot still going on, just analyzing all of the data to try and figure out what the heck is going on. Because it's weird and so different than we expected. And I love it. And I'm so glad that people are respecting how amazing Pluto is, because it's amazing. We are Pluto stands in the planetarium, okay?
Support Pluto.
So yeah, yeah. There you go. Wasn't I with you? I was living with you when this happened. How did you not? Anyway, that's a conversation we can have offline. Okay. All right. Let's wait, see if we get any more questions or comments. Louise, did you have any fun things?
Yes, I have two things that I can talk about for a little bit.
Go for it.
The first thing is going to be more of a James Webb kind of update. Uh, they released some new pictures and some new cool things, obviously, of some exoplanets. The big one, though, that I found was exoplanet about 40 light years away from us. I think it's I have it in front of me actually, VHS 1256b. And so this is basically a massive kind of gaseous planet, exoplanet. I believe I saw it was like 19 times bigger than Jupiter, but it's so far away from its two stars that it rotates around that the James Webb was able to use direct imaging to actually see the composition of the planet instead of using the sun's light as a background filter, basically. And so that's kind of a big deal because this is the first time James Webb has been actually able to do that kind of imaging to find compositions, which is pretty cool. The findings that they had is, let me see, they found that they had like silicate clouds. So it's basically, it's kind of like raining quartz and kind of like those like minerally ideas. But then they found a whole bunch of other things like water, methane, and carbon monoxide and dioxide in smaller amounts. And so that's kind of like the big thing happening with the James Webb that was published today. So
I think
that's
I saw
pretty
it. That's
cool.
the one that they were talking, yeah, that had the clouds of sand.
Mm-hmm.
Oh,
Yep.
that's so cool.
So I mean,
Someone needs to like make a movie about this stuff, or I don't know, like I feel like hearing about these things, it'd just be such a cool like idea for like a movie or like a setting for like a movie or something. I don't know, it just seems so like far out, but like it's
yeah,
real, so
19 times the size of Jupiter is massive already.
I'm assuming that's mass and not
I saw a
radius.
size.
Is it size? Is it radius? I didn't think. No, it's mass.
Oh, massive.
Yeah,
Yeah.
because
So it's dense.
planets, yeah, planets, they don't actually get much bigger than about twice the size of Jupiter, because they're made of
Okay.
things that easily compress. As you start adding in more mass, it actually compresses. So
Hmm.
it just gets denser rather than getting bigger.
Okay. So that's
It's
this case there
yeah,
then.
yeah. So that's why we
Um,
find even like brown dwarfs and failed, those are failed stars, and the smallest of stars. They're not that much bigger than Jupiter. They're just a lot denser because they have so much more material packed in.
mhm,
It's cool.
yeah. Um, yes. And then I guess the next thing that I had is more earthly based.
Oh,
With
one question. We had
question.
someone asking the name of the exoplanet again.
Oh yes. VHS 1256b.
There we go.
I don't know. I can.
That works. Thank you.
Sounds good. And then the next one is more earthly based with some northern lights. I guess we're projected here in the north. We are projected to get a big kind of aurora effect happening this Friday. Did anyone else see that?
I think I saw that.
Yeah.
I have to
There.
make sure camera's
I
running.
mean, oh yeah, no worries. But yeah, I guess we have some aurora like activity that could be happening here, and it's clear. So that's basically my update. Is it looks fairly clear that night.
Nice. Yeah, I know we had like a recent active burst on the sun. So I'm not surprised to hear
Hmm.
that aurora forecast is looking good for this weekend. Because it generally takes a couple of days for the stuff to reach the Earth. We see it ahead of time because the light gets here really fast, but the actual particles and gas that's being expelled travels a lot slower than light does. So it takes it a couple of days to get
Hmm.
to us. So yeah, if you want to see how things are looking, you can always check out the Chickawauk All Sky camera. Link in the description because it's awesome and I will make sure it's running. We've had some issues the past few weeks, but they've gotten so much snow up there. I'm not surprised. Winter, we usually have some power troubles with the camera. But yeah, very cool. All right. Let's see. Oh, that's an interesting question. Is Pluto a moon of Neptune? It's harmonically locked. So is it a new type of moon that he is making up right now? So, very interesting thoughts there. This harmonically locked that was mentioned, basically Pluto and Neptune are in a resonance. I think it's a 3-5. I don't remember the exact, but basically there's an integer number of times that Neptune orbits the sun that Pluto also orbits. So if it is 3-5, then it would be Neptune orbits 5 times and the same amount of time that it takes Pluto to orbit 3 times. I don't think I'm right on the 3-5. I think it's a different, but that's what it would mean. And it's actually because of this why Pluto and Neptune are never going to run into each other, because their orbits do technically cross, but because of this, because of the harmony in their orbits, they're actually always on the opposite side of the sun from each other. So they're never going to run into each other. And there's a lot of other objects around Pluto in the Kuiper Belt that have the same resonance with Neptune. They're called Plutinos. And it's one of the reasons we think these sets of objects survived, because they were always on opposite sides of the sun from Neptune. Neptune was never able to gravitationally sling them out of the solar system. So they're still here because they've survived. I don't think we can use that as a basis for a moon, because Pluto does go around the sun. It is an interesting thing to think about, though. But Neptune does have a moon that is very Pluto-like, which is the moon Triton. Actually started out in the Kuiper Belt with Pluto, and then Neptune captured it. So there is a Pluto-like moon of Neptune, but not Pluto. Still pretty cool. I love talking about Pluto. All right. I think we will take one more call. It's 3-2 resonance. Okay, thank you. I knew it was 3 something. 3-2. So for Neptune goes 3 times around the sun for every Pluto going around twice. Okay. I have sick brain, so I'm happy I at least got the 3 right. So yeah, we'll take one more call for questions. In the meantime, let me show you what is coming up this next week. So for our in-person shows this week, Friday is going to be Expedition Moons. Saturday at 2 p.m., our family show is Two Small Pieces of Glass, and 7 p.m. general public show is Europe to the Stars. This is the last weekend that we will be showing these 2 shows on Saturday, because next weekend is Astronomy Day. So next Saturday is Astronomy Day, and we've got so much fun stuff planned. You can check the link in our video for link to the website. It's got all sorts of information, our show schedule. We're going to have an amazing raffle with some fantastic prizes, including a little tabletop telescope, which I'm so, oops, wrong button. So excited. We have a meteorite donated by Bob King that is going to be a part of the raffle. I know. Yeah, you were at the meeting the other week when I said that.
I did not know about this. Oh my gosh.
Yes.
That is so cool. Well, not
Gotta
everyone
flood
has
the
got to come to
boxes.
Astronomy Day. That is so cool.
Yes, we are very, very thankful to Bob for that donation. So yeah, we've got a tabletop telescope, a meteorite sample, and then our third raffle prize is a signed copy of one of Bob's books, and a Planetarium water bottle and bookmark. So fun little third raffle prize. It's gonna be great. So yeah, Astronomy Day next Saturday, 6 to 9. It's gonna be fantastic. Come join us. Even if the weather isn't great and we can't do telescope viewing outside, we will still have lots of fun stuff going on inside. So come see us. But also put out your fans to blow away the clouds so that we can do telescope viewing that night. All right. And then, yeah, as I was saying, after Astronomy Day, then our Saturday shows will change to a new set of shows. So if you want to see those two shows, this weekend is going to be the last chance for now. They will come back eventually because we do rotate through our shows, but it'll be a little while before they're back. So, yeah. I'm going to cough again. Hold on. Sorry, I muted the stream and I didn't mute you guys. So I apologize. All right, I think I'm not seeing any more questions, so I think we will wrap it up there. Thank you everyone so much for joining us. And if you do end up thinking of more questions in the future, we run Ask an Astronomer every month. So you can always come back in April and ask us those questions then. Until then, though, have a wonderful week and we'll see you next time. Bye, everyone.